In this example, we have another rational expression, so let's take a look at the first fraction. We have 5a over 3a squared minus 11a minus 4 times the second rational expression, which is 3a squared minus 5a minus 2 over 5a squared minus 10a. Now, you're going to use the same technique, basically check which part you can factor. If I examine this example closely, I know that in the denominator of the first fraction, we have a trinomial, which you can factor. In the second rational expression, if you look at the numerator, it's another trinomial, which you can factor. In the denominator, we have the binomial, meaning two terms, which you can factor by GCF. So like I said before, you're going to use the same techniques that you did in the previous videos, in the previous example. What I'm not going to do is write out the work for factoring, because I have limited amount of space, but I do recommend that you pause this video, work out each part by factoring so that you have to work in your notes so that you can understand the process. So again, I'm not going to write out the work here since I'm in a limited space, but I do recommend that you pause the video, work out when you're factoring each part, and then make sure that your factors match with mine. So I'm going to skip the work. So for the first rational expression, the numerator stays the same, which is 5a. Now for the denominator, when you factor, you should have gotten 3a plus 1 times a minus 4. Now if you didn't, I highly recommend that you double check your work before moving on. Alright, in the numerator of the second rational expression, you should have gotten 3a plus 1 times a minus 2. And again, if you didn't get the same factors, pause this video and then double check the work before moving on. Lastly, for the denominator, the factors are 5a times a minus 2. Alright, so these are the factors that you should have gotten as you're doing all the work. Now, since it's multiplying, I'm going to put the numerator factors next to each other, put the denominator factors next to each other. So, I'm going to have 5a, parenthesis because I'm going to be multiplying, to the 3a plus 1 and a minus 2 over 3a plus 1 a minus 4 times 5a from here times a minus 2. Okay, so I put the factors next to each other, meaning I combine the numerator with numerator and denominator with denominator. Next, I'm going to simplify by dividing common factors. So I notice I have 1 3a plus 1 in the numerator and in the denominator. So when I divide, these will become 1. I also notice I have a 5a in the numerator and denominator, so I'm going to divide and both of them will become 1. In addition, I have 1 a minus 2, meaning one factor of a minus 2 in the numerator and one factor of a minus 2 in the denominator. So when I divide them, both of them will become 1. So let's write out what we have. In the numerator, I have 1 times 1 times 1 from these three ones here. In the denominator, I have 1 times a minus 4 times 1 times 1. So I'm just doing this step by step. In the numerator, I have 1 times 1 times 1, which is just basically 1. In my denominator, I have 1 times the factor a minus 4 times 1 again, simply means the factor a minus 4. Since I only have this factor, the expression in the denominator, I don't have to include parentheses, but it's okay if you do. So checking my answer, there's nothing I can do to simplify it any further, so this will be my final answer. So again, to review this example, here I wrote this step by step, meaning when I divide common factors, they all become 1, and I rewrote them here to remind myself that in the numerator, I still have 1 times 1 times 1, which is just 1. And then in the denominator, I have 1 times the factor a minus 4 times 1 times 1, which is a minus 4. And then when I rewrote and finalize my answer, it's still in the shape and the form of a fraction. Now, I have students where in the numerator it was just 1 times 1 times 1. They thought it was just a regular a minus 4, whereas your answer should have been 1 over a minus 4. So that's why here I wrote this part step by step to illustrate that the 1s does not disappear. It's there, so that way you can see that in my numerator I have 1, because from here 1 times 1 times 1, which came from over here, when you simplify, meaning divide common factors, they all become 1, meaning didn't really disappear, it just become 1.